Now let's talk about chemical reactions. We talked a lot about these bonds, and remember, like I said, bonds between atoms are like relationships, right? So chemical reactions are like dynamic things that happen and changes that happen in relationships. So the thing is that with a chemical reaction, these bonds are formed or broken. Like bonds are formed and broken between people all the time. Same with atoms. So reactants is where you start, your starting point. So these are the reactants, and the products, when you produce something, you produce a product, right? So reactants are the starting materials, products are the end result. Now metabolism, there's many, when you talk about someone, ask them what metabolism is, they might say like, oh yeah, it's how fast you burn off things and your calories, and whether you're skinny or you're overweight or other things like that. Well, the physiology definition of metabolism is the sum of all the chemical reactions occurring in your body. So your body has all of these chemicals that, you are made out of chemicals, and there are many of these reactions that are fueling your body, repairing your body, and keeping your cells alive. So all of those put together is what we call metabolism. So it's not just about calories and energy expenditure. It does involve it, but we're talking about all the chemicals. So the types of chemical reactions I want you to know. So there are main categories. There are other types of chemical reactions, but these are ones you should definitely know for this class. So decomposition reaction, and also known, sometimes called a catabolic reaction. So when you think of a catastrophe, that's when things fall apart, right? So when something decomposes, what happens? Well, when you think of something like an organism, like you see leaves decomposing, you think of them rotting away and breaking down. So that's what happens during a decomposition reaction. Things start to break down into smaller parts. Now, it doesn't necessarily, this is a type of decomposition, but this is the way you can think of it. Decomposition means things are falling apart. And then synthesis, the opposite of that is what we call a synthesis reaction, sometimes referred to as an anabolic reaction. So the opposite of something breaking apart is building something up, right? So when you think of anabolic, what do you think of? Sometimes you might think of anabolic, steroids, or things that build up something. So what we have, when you think of synthesis though, you're thinking of making something and out of smaller parts. So when you're synthesizing something like this with this 3D printer, you're building something up. So decomposition, breaking down; synthesis, building up. Now an exchange reaction, well, exchange reactions are what happens when you exchange something. Like say you exchange like dollars for pesos, or like you exchange Canadian dollars for American dollars. Well, you're giving something, but you're also getting something in return, right? So exchange reaction, you have some sort of exchange. It's not that we're completely building something or giving things away, or things are breaking down or being built up. There is some sort of switcheroo. And a reversible reaction, well, if they're like things like the decomposing food we saw earlier, is that food going to go from rotted back to full fresh fruit again? Well, it probably has to go through that whole cycle of the life cycle of a plant. But reversible reaction is something that can go back and forth. So, okay, so analogy time. I love analogies. So remember, I like to draw an analogy between chemistry and atoms and people and relationships. And chemical reactions are all about the changes in relationships between atoms. So what we have here, we started off with two reactants, and after their products are, now we have two reactants that came together to form a new molecule. So this is a synthesis reaction. So when you're synthesizing a new relationship, you're building a new bond, right? So this is what a synthesis reaction does. It builds new bonds to create a new molecule. So this is why it's also sometimes called an anabolic reaction. You're synthesizing a new bond, you're synthesizing a new relationship between these atoms. So again, these are the reactants. So you have two reactants, but now you have one larger product that's bigger than both of those reactants individually. Now, what's the opposite of that? Remember how I said the opposite of synthesis is decomposition? Well, what's the opposite of making a new relationship? The opposite of making a new relationship is breaking up, right? So decomposition reaction is like that. It's like a breaking up between atoms. So here's our reactant. You started off with these two atoms that were in a relationship and they're bonded together, but now they broke apart. So reactant, and now you have products that are individually smaller than the initial reactant. So this is also why it's called a catabolic reaction. Now, exchange reaction. So what happens here? Well, do we necessarily break these apart into smaller molecules? Not really. But what we have here is that we have these initial reactants, but notice that one component, or actually two components, or you could actually think of it either way. Notice that components switched between these two bonds. So these are long off the air, but back in like the early 2000s, there were all these like trashy reality TV shows where people would actually like trade like their partners for a week or so, and then all this drama would happen. So it's kind of like that. So what happens is that you switch partners, and this is what exchange reaction is like. The reactants and products are different, and you still have the same individual components, but now they're rearranged differently. So exchange reaction is some sort of switcheroo. Okay, and then now if you've had a friend like this, remember my analogy is that chemical bonds are kind of like relationships, and you might know somebody who's been in this type of relationship. So they start out in a new relationship, they break up, they get together, they break up, they get together, break up, they get together. Sometimes they're more broken up and taking a break more than they are together. Sometimes they're together more often than they're broken up. So these sort of back and forth reactions where they have these kind of being put in, or they're forming new bonds and breaking new bonds, this is what we call a reversible reaction. So it can go both ways. You can have a synthesis, you can have a decomposition. Either way, this reaction isn't just it's not a one-way street. You can build a new molecule, or you can break it up in a catabolic reaction. So that's what reversible is, and this is why in the chemical notation, when we're showing these like reactions, this is why there's a double arrow, because it can go either way. So these are, yeah, that's by the way, if you're in that, please really think about your choices, because yeah, that sort of codependency is toxic. Yeah, I agree with the chat. So yeah, there's already enough stress in the world. You need that additional stress. So these are the basic categories of chemical reactions you should know for this class, especially when you get to PHYL 142. There's a lot of reversible reactions. Actually, reversible reactions are very important for chemical solutions we call buffers. Okay, so A plus B makes a new molecule AB. So what type of reaction is this? Well, multiple things can apply to this, and the correct answer is, looks like most of you got the right answer. So it is a synthesis reaction because you're forming a new bond between these individual components A and B. But it's also anabolic because now you're building and synthesizing new bonds and building a new larger molecule. So that's why it's also anabolic. It's not catabolic because it's not falling apart. And it's not reversible because look at the arrow. It's one way in this equation.